Alright, in this video we're going to look at examples of implicit differentiation. And remember that implicit differentiation is just an extension of the chain rule. And we normally say dy over dx, the derivative of y with respect to x, is dy over du times du over dx. And u is going to be some function, or some equation, not some function, some equation of y. Now, we can rewrite this a little bit, and we can say the derivative of u with respect to x is going to be du over dy times dy over dx. Now, the reason we're doing this is because u is some equation of y, so that's going to be y squared, y cubed, 3y, something along those lines. So we can find the derivative of that, and then we're going to bring along for the ride dy dx. Alright, so let's look at an example. So we got x squared plus y squared equals 1. So we're going to take the derivative of this equation, and we're going to take the derivative of each piece. So the derivative of x squared with respect to x plus the derivative of y squared with respect to x equals the derivative of 1 with respect to x. Alright, the first piece is nice and easy. We've got our matching variables x and with respect to x squared with respect to x, so we can find that. That's going to be 2x. Our second part, now we've got y squared and x, so we can't find the derivative of that. So we're going to use the idea of u being some equation of y. So we can still use the chain rule, and what we're going to come up with is 2y times dy over dx. Alright, so that's using the rewritten notation, or the rewritten chain rule in the orange. And then the last part is 0, right? The derivative of 1 with respect to x we know is going to be 0. So we're trying to find the derivative of y with respect to x. So we've got to get that thing by itself. So we're going to get rid of 2x. We're going to subtract it from both sides. And we've got 2y times dy over dx equals negative 2x. We're going to divide both sides by 2y. We know those cancel out. dy over dx equals, well, our 2's are also going to cancel out, so we're left with negative x over y. And that is the derivative of x squared plus y squared equals 1. Alright, let's look at another example. 2y equals x squared plus sine y. Alright, so we again are going to take the derivative with respect for everything in here. When our variables don't match, we'll use the orange side. When the variables do match, we'll use the green side up along the top there. So, the derivative of 2y with respect to x equals the derivative of x squared with respect to x plus the derivative of sine y with respect to x. Alright, so the first piece we can't do as it is, so we're going to use the chain rule. We're going to find the derivative of 2y, and then we're going to multiply that by dy of dx, and we get 2 times dy of dx. That equals 2x, our variables match, and the last piece, we're going to find the derivative of sine y, which is cosine y, times dy over dx. Alright, so we want to get our dy and dx on the same side, so we're going to move that over to the left, and we get 2 times dy over dx minus cosine y dy over dx. And that equals 2x. We can see both of these things are multiplied by dy over dx, so we're going to factor those out. And we get dy over dx equals, or times 2 minus cosine y equals 2x. Getting dy dx by itself, we divide both sides by 2 minus cosine y. And of course we are left with dy over dx equaling 2x over 2 minus cosine y. Alright, let's look at one more example. It's going to be a little bit bigger of an example. And we're looking at 3 times x squared plus y squared, all squared, equals 100xy. Ooh, it's going to be it's a big one. So we're going to take everything, the derivative, with respect to x for all of this. So if we were just looking at this to begin with, the 3 times x squared plus y squared, all squared, we would look at the outside piece first, and we would find the derivative of that. Alright, and the 3 comes along for the ride. So 3 times 2 times x squared plus y squared times the derivative of the inside. All right, so now we're going to take the derivative of x squared with respect to x. We're going to take the derivative of y squared with respect to x. Derivative of x squared with respect to x is 2x. Derivative of y squared with respect to x, now we're going to use that idea of incorporating the u in there, and we're going to take 2y times dy over dx. All right, so that's the left side of the equation. Now we need to do it to the right side of the equation. And we've got the product rule, so we've got x times y. So we've got to use the product rule, so we're going to take the derivative of we're going to take x times the derivative of y plus the derivative of x, which is 1 times y. Alright, so now we're going to try and get ultimately our dy over dx by itself. But to begin with, let's distribute a little bit, so we get 6x squared plus 6y squared, and we've got that times 2x plus 2y dy dx equals 100x dy dx plus 100y. Alright, so 12x cubed, we're just doing foiling or distributing this whole side, so 12x cubed, 6x squared times 2y, so we got 12x squared y dy dx, and then our 6y squared, we're going to distribute that, and we get 12xy squared, and we get 12y cubed dy dx. And then on the other side of the equation we got 100x dy dx plus 100y. Okay, so we're going to need to get the dy dx to this side, and we're going to need to get these two non-dy dx's to the other side. So we're going to move all of those over in one fell swoop, and we have 12x squared y dy dx plus 12y cubed dy dx minus 100x dy dx equals 100y minus 12x cubed minus 12xy squared. Whew. Okay, so now we're going to factor out our dy dx, and we're going to be left with 12x squared y plus 12y cubed minus 100x on the left, and on the right we have 100y minus 12x cubed minus 12xy squared. Okay, so we're going to do a big division here. So we're going to divide all of this on the left with everything on the right, right? But before we do that, I'm going to bring this 100 out in front, so that way you can kind of see that we've got a lot of matching, matching type numbers. So we're going to have minus 100x plus 12x squared y plus 12y cubed. All right, so these two things cancel out. We're left with dy over dx equaling 100. Now I'm going to start, let's see, 100y, and I'm going to start factoring a little bit here. I can see that there's a common factor of 12x, so I'm going to bring that out, and I'm left with x squared plus y squared. And then in the denominator, we're going to have minus 100x, and again we've got some common pieces here, 12y, so we're going to factor out a 12y, and we get x squared plus y squared remaining. Now, wouldn't it be nice if we could do some extra canceling and maybe look at this and say, well, look, we've got two things here that are the same in the numerator and the denominator. But remember that this isn't a factor of both parts in the numerator and both parts in the denominator, so that cannot be canceled. That can't be simplified. However, if we look at the other parts, the other aspects, we have an x and a y, so we can't just cancel those, but we can look at what's common between 112 and 112. So we can factor out, what is that, a 4? And we know if we factor out 4 from everything, it will cancel and simplify down, and we're left with 25y minus 3x times x squared plus y squared over negative 25x plus 3y x squared y squared. And that is our final answer for this this equation. So I hope these examples kind of help. It's really just a lot of algebra and remembering that you're using dy over dx as kind of an operator, the derivative as an operator. So good luck with these, and we'll talk to you soon.